Now, some folks have wondered where all this sand comes from. And a lot of people think that it's currently coming down from all the rivers that we have draining the state of North Carolina and coming down to the coast. The fact is, those rivers really bring very little sand down to the ocean system right now. A lot of this sand is left over from the last ice age and the continental shelf and rivers that flowed across the exposed continental shelf thousands of years ago. And as sea level came up, it just kind of kept pushing this sand like a bulldozer back toward shore. So this is really old sand that just hasn't gotten here in the last couple years. Now, what's the sand made of? For the most part here in North Carolina, most of our sand is made up of quartz. And quartz is one of the most common minerals in the world, and it's a very durable mineral, so it doesn't break down when it's exposed to water and wind and all sorts of other natural physical and chemical processes. And if you look closely in there, and sometimes when you're at the beach, you'll see some dark specks in there, and that's some of the darker minerals that exist. And many times if you have a magnet in your pocket, you can drag it along those dark areas, and some of those minerals will actually stick to the magnet because they've got iron in them, or they are themselves magnetic. There's actually a mineral called magnetite that's a very black mineral. And then you'll notice some other specks in there that are little pieces of broken shell. And we know these are broken shell because we can do what we call the acid test, and everybody loves the acid test. So we're going to go over here to my pile of stuff. And so right here I've just got a container full of seashells. You guys admit, what do you think those are? Pieces of shell?
Yeah.
I think those come from a clam. Those are quahog shells. They're really thick and big, but they're made up of a mineral called calcite or aragonite. It's essentially the same chemical formula, and it's calcium carbonate. And if we spray some acid on there, notice how it bubbles up? Are you brave enough to have it in your hand?
Yeah.
It won't hurt you. And so this is one of the tests that we use. Now you can do this trick at home with vinegar. If you've got a shell at home in your collection and you want to put some vinegar on it, it should fizz because vinegar is acidic as well. And this is very, very, very diluted acid. Never play with acid. This is something that the scientists dilute down, and we know how to do it. We've had years of training to do it. So definitely, if you're going to do this, only do it with vinegar. But so I've just shown you how the big chunks of shell fizz. Well, what happens, you'll notice these are pieces of shell already. So how do you think they got into pieces? I'll ask the students here. Kira, Ben, Jada, you want to guess?
Maybe it took years and layers came on it.
Yeah, well, that's an interesting observation. All the layers in the shell. And those layers are there as the animal grew, as the shell grew in age. So those are kind of like tree rings, but in a shell. So you can kind of see that shell took many years and grew layer by layer by layer. But since these used to be big, complete shells, and now they're broken up, there was something that broke them up, and it happened to be that the wave energy, if you've ever gone out and walked in the surf, it's pretty powerful, and it can knock you down. And if you're to throw shells out there, as they just get pummeled by wave after wave after wave over years and years and years, they'll break up. And these happen to be large pieces, but eventually they'll break up into even smaller pieces. So if we can get the camera on here, this came out of this beach that we're standing on right now. I kind of sieved the sand out, and I got all these little shell pieces. And these aren't necessarily pieces of the same shell, but these are animals that have shell. It's not the same type of clam. So we're going to do the acid test again. I want you to see. You think this is going to fizz, guys?
Yes.
Whoa. Wow.
Absolutely. So what we can do is you can also just pick up plain sand from the beach, which is what we'll do here. And now I mentioned before that there are a lot of other things that make up the sand that you walk on, and we can pour some of the acid in, and you'll notice there is some fizzing in there. It's not as much as when we poured it straight into all the shell material, because a lot of this stuff in here doesn't react with the acid. It doesn't react, the quartz doesn't react with the acid and the other minerals. It's only the shell material that does. So for those that may have missed it, we'll throw in some more.
Jeff, what percentage of the beach do you think is actually composed of shell?
For most of these beaches out here, the content is right around 10% on average. When you go over to Shackelford Banks, interestingly enough, it's one of the shelliest beaches on the ocean front. If you get up to Dare County and the Outer Banks, if anybody's ever visited the Nags Head, Kitty Hawk area, they have a lot of shell up there, but Shackelford can get up to 19-20% carbonate material. And so when you take a big sample of sand, that means about 1/5 of it is actually made up of shell pieces. I mentioned that a lot of this sediment is pieces of broken up shell, and when we call something sand, it's really just a size we're talking about, a certain grain size. And sand, defined by a geologist, happens to be between 0.06 millimeters and 2 millimeters in diameter. So it's a very generic term, and it can be any type of mineral. So some of the shells could be old shells from thousands of years ago that are broken up. They could be shells that just died in the last couple months and got broken up in the surf. When they become so small, it's almost impossible to tell. But if they're older, you can do a lot of fancy laboratory techniques, such as kind of looking at their chemistry and looking at the isotopes that helped form the actual minerals in there. The minerals themselves, you can talk about when the islands formed, but some of these minerals, I said they were left from the last ice age on the continental shelf. Well, they could have been there for millions of years, and just as the seas came up and down and up and down, they just continue to get reworked and pushed around. At one point, all these quartz minerals and these heavy minerals that we call that some were magnetic and some had iron in them, all came from the west and were carried down by the rivers to the continental shelf. And over time, they become smaller and smaller and smaller and were transported in the rivers. So they're the age of the original rock they came from, and that could be tens to hundreds of million years old. But yet the formation they've come together to form, like a dune, could only be a year old. So while the structure may be a year old, the material that makes it up could be 100 million years old. So it's a tough question to answer, but a really good question. And if you're interested in geology, that's what geologists do. That's what some of us do.